I am the inventor of the system, and this is a process that is going to be enhanced by clinical studies. In 2006, I have the idea of this fixation system. This fixation system is just about a device that goes freely on a key wire, a smooth key wire, and the device, small device, it goes freely on the key wire, but when you try to pull it back, it does not come back. You may also try it.
كانت بتفطر معايا النهارده الصبح. الدكتور فريرة ليزا فريرة كانت بتفطر معايا النهارده الصبح. هي موجودة كده في كان أفضل الشخص ده يقدم ورك شوب لأنه هو معاه حالات كان ممكن فعلا في الشكل ده يتردد مع الناس. كان أحسن يعمل ورك شوب من غير ما يعمل شغل.
I had the idea and dream about this device, or this fixation system, and my dream was like this. I don't know the cause of this problem, but I'm going to try again. Anyway, we may continue later. And you didn't try the system? Yeah, it goes freely.
Full. So full.
Pull it now.
Yeah.
Oh, it goes freely, but doesn't come back.
Just 1 second.
Right. And one more thing I want to show you.
It's amazing.
One-way dog clutch mechanism?
Yeah.
Okay.
1 minute.
One-way dog
And
clutch. Okay.
one more thing. I'm trying to pull it back. It does not come back. You may also try it. Try to pull it.
Pull it.
Okay. You may take out the implant with a magnet. It's so simple. You may also try it.
morning we're pulling صغير بنحطه في الملابس عشان ما تتسرقش. بتطلع بالمغناطيس بتطلع بالمغناطيس.
فكرة هي في سمارت.
لو كنت عايز اقول لحضرتك عليها هم دلوقتي مديني شهادة لحضرتك.
لا خلاص ادينا خدها كده.
لا علشان الكوشير هم اقول لحضرتك هو هم في اخر برنامج اتغيروا عملوا شهادة. خيف هتبقى شكلها وحش ده لحضرتك وما اديله
we took the patent approval for this, and then we made our first biomechanical study. It was on the video, but I could not show you. Anyway, in that study, sorry. We tighten the system and then make destruction force to these systems. These systems hold 92 kilograms of destruction force. It was a good value for us. And then we apply cyclic loading to these systems, and the mean value was 45 kilograms at the cyclic loadings, and there was no failure of the system. And then we say, yes, we got the biomechanical strength. Yes, we may go on to next step. And then in 2011 and in 2012, we made our first fracture simulation study. We made a fracture line in here. We fixed them with 3 pairs of EFECE systems, compressed the system, locked the system, and then apply compression force. Our results were, we were expecting EFECE failures, but we did not get an EFECE failure. The key wires elongate, and then the system holds 2,500 newtons. And the mean destruction was 22.5 millimeter. After these experiments, we gained the knowledge that we need to decrease the diameter of these EFECEs. They look so bulky, as you see in here. This is the rear leg of ships. But we got to decrease the diameter of these devices, and we got to change its composition. We've got male part in here, upper part is male, lower part is male, upper part is female. We got to change this composition because surgical technique will be so difficult. And then we made animal studies 1 year later. We insert EFECE devices to these rats' dorsums, 2 EFECE devices. Then we took them, one of them at the 6 month, the other one at the 1 year. We'll look at the environment of the device, and pathologically we evaluated. There were no inflammatory response, and these are the devices that we extract. But in devices, we saw that a little bit corrosion. The mechanism of locking is with the help of these balls. These balls are in a cone-shaped globe. When you push the device, balls move to the base of the cone and release the key wire. But when you pull it back, balls move to the top of the cone and lock the system. When you hold it, it catches more. And these balls are magnetic active. When you apply a magnet to these dorsum of these devices, magnets pull the device, the balls, and then the key wire releases. After these 3 experiments, we said that corrosion will be a problem for us. And for this problem, we've got 3 chances. We may coat the balls, or we may change the alloy of the balls, and also we may change the implant removal technique. For this coating, in US, companies got the knowledge about this, but in Turkey, we could not be able to get this technology in our country. And also, magnetic active alloys could not be reached by us in Turkey. We could not gain this knowledge, and because of it, we changed the implant removal technique. And also in 2013, in Genoa, this innovation got the silver medal as best invention, and this get us more active. And in 2014, we made our first cadaver study. With the results of previous research, we made smaller EFECE devices, as you see in here. The diameter of the device decreased 2 millimeter. These devices are with 8 millimeter. These are with 6 millimeter. we've got non-magnetic balls inside it. And the ball's radius is 1.5 millimeter. And you may also see we changed the composition of the system. In the condylar fracture simulation, we've got only one pair of EFECE system on it, and you may feel the fixation strength. And also in here, we've got a condylar fracture simulation. You may also see the strength of fixation. And for a new surgical technique, we define new tools. We got to define new tools because we've got no defined surgical tools to make this surgery. After defining these devices, we simulate patellar fracture and then fix it with EFECE systems percutaneously. This is the side view of this fracture simulation. And also, we made syndesmosis injury simulation, fix it with 2 pair of EFECE systems. And we now say that our surgical technique is working correctly. As in surgical technique, first we reduce the fracture, then insert the key wire. On the other side, we insert the sleeve after a stop incision. We go to the bone cortex and then insert this working cannula on this sleeve. On this sleeve. Then we are taking out the sleeve. We've got a working cannula in it, and we are getting the EFECE system onto the bone. I will make a workshop about it. You may see patellar fracture simulation. We got 2 pairs. We insert a key wire. I already insert the EFECE system on it.
So you remove the magnetic balls and then you remove this with tools?
Yeah, okay, of course.
Okay.
I'm going to show the fixation strength. We'll lock the EFECE system on one side, and then with a stub incision on the counter side, I'll load the EFECE system on this handle.
كلامك صح.
I made a stub incision, I insert the sleeve, I then insert this working cannula on it. I'll also show it. This is the sleeve. I made a stub incision. I go to the board and then insert this working cannula. I take this out and then I load the EFECE with the handles. One of them is EFECE holder, the other one is screwdriver. With the male side. I'm addressing it. Hold this. Okay. And insert this system, and then I'm using a wire stretcher. We have already used in orthopedic surgery. I have inserted, and I catch the key wire, and then stretch the key wire now by turning this. I may feel the stretching of the key wire. Yeah, again the stretching. You may feel the
correct actually.
yeah. And after this position, I am locking the EFECE system. I'm feeling the tension on it. Okay. And then detaching the wire stretcher, and then taking out the. This is the fixation. We may also insert other key wire to fracture line. If you want, I may show you. And then after the procedure, we may cut key wire remaining parts with this tool. This is the fixation. Surgery time is nearly 10 minutes. In our conventional patellar fracture treatment, we made a nearly 10 centimeter incision on patella. We reduced the fractured fragments. Then we use a reduction clamp, and then we insert two key wires parallel to each other, and then apply a cerclage wire on it. We cross the key wires and then begin to tighten it. And then we lay it on the cortex and then close the wound. Our incision is nearly 10 centimeter in length, and implant removal is like it. We are making an incision in 10 centimeter in length, and then we go to the key wires, cut them, and take them out. But implant removal with this technique will be with four step incisions, and surgery time will be, I think, less than 10 minutes. What are the disadvantages of these systems? They are addicted to key wire properties, and because of it, we define EFECE wires. Their molecular alloy ratios are important for us, and because of it, we got to define EFECE wires. And to be approved, we need a lot of study, because this is a newly fixation system, and to get the approval from countries will be a very long way. And for me, this is an important thing. Being in a developing country and making an innovation is so difficult. You are wasting your time with unexpected things, and getting this project to here took nearly 9 years for me. And being in a developed country might decrease this amount. What are the advantages of EFECE systems? The system is completely minimally invasive and easy surgery. Our fixation is free of bone quality. Fixation with thin wires is a new concept. We may apply compression to the fracture line and gain callus at the early time. And this is the endpoint for this project. And from now on, we are trying to get the GE certificate for our country, and then our ministry is asking for the license. We will try to take the license, and then we will be able to get the clinical studies. And I wish we could gain a new fixation system in orthopedic surgery. And also, I wish we could be able to enhance these systems. Thank you. Thank you.
Any questions? Now, do you envision using this system on other fractures? Because you are saying only knee fracture, knee fracture.
No, not only knee fractures, at metaphyseal fractures, we may use them. For example, elbow, wrist fractures, distal and proximal femoral fractures, proximal and distal tibial fractures we may use. And if we define the micro types of these fixation systems, we may also use them in sports medicine. In sports medicine, arthroscopically, we are using nuts, a lot of nuts, to get two tissues together. But with EFECE systems, micro EFECE systems, we do not need nuts. We may insert the key wire and then advance the EFECE system, then knock it. And then the surgery is completely finished.
You indicated that before you go to market, what are the different steps you need to do before you market this device?
First of all, these devices that we define are not magnetic active, and implant removal is not with magnets in these systems. Because of it, we may get a GE certificate. It's going on, and we think that we get the biocompatibility tests correct. And this will be enough, we think, for GE certification in Turkey. But in US, FDA certification might be a problem for us. But we will talk and try to take it.
Okay. That is very interesting concept.
Thank you.
Any questions from the floor?
For the devices that I've shown to you, they are stainless steel, 316L. But we are trying for magnetic active balls coating with titanium. If we could be able to achieve this technology, we might turn to titanium technologies. But we are not sure about getting the license for titanium-coated balls. Mr. Ferreira will tell for us, I think. Okay. Okay, thank you. Yes.
Question.
What first got you interested in applying this device to a bone fracture? Did someone break their leg in your life or something?
No. We are every day going to the markets, don't we? We are going to the markets, and there are security tags at there. Do you know them? The worker is at there is taking the security tag and then taking it out with a device. Do you know it? That is the magnet, and the system is with these balls. I first got the idea about it after following over this tag. I look at the tag. There was a straight key wire. I'm pulling it, but I could not get it back. This might be a problem solution in orthopedic surgery. And then I asked to get them. They don't allow me to get them. But I tried, I take it, and then find the system and the knowledge about it in it. I got that, and then get it real. Thank you.
I have a question. You use stainless steel material. So what about the cell adhesion and when you want to remove it after correction? So is there a problem to remove it?
Yeah. We could not be able to get magnetic active balls for this time. And then we defined tools not to detach the upper part of the system. We are a little bit releasing the male part of the upper part and then turning the FJ holder. And then balls, in our fixation, balls are getting into the QI and making a hole on it. When you turn it, balls go to their original parts. When you rotate the system, balls go to the lateral and then release the QI.
I don't ask about the heads. I talk about the wire, which inside the bone. When you want to remove this wire, when you finish, is there a problem to remove it? It will be, there is any type of adhesion to resist it is removing?
And then open this part, it's rotating, and I will take it out. Go to counterpart. I put the key wire from the other side, and I have a lash for it. I'm inserting the lash. I'm taking.
No, it's okay.
Yeah. You may take the machine. Screen one. Sorry, QIR.
Okay, thank you.
Any more questions?
So, did you do any in vivo studies? Like, did you actually
If you are saying in vivo animal studies, we made a little bit study with magnetic active balls. We did not coat them. And first we thought that we don't have direct contact to the tissue, because when you insert the key wire in these devices, there is no ball tissue contact. There won't be a corrosion problem or an inflammatory problem, but our thoughts were wrong. We saw corrosion on these balls, and then say that in vivo we got to coat these balls, as I said in this session. For clinical studies, we got to take approvals from our ministry, and then we will make clinical studies.
Because I noticed when, I guess where the wires are, when you cut them, are really, really sharp. Do you plan on like covering this with something? Because that would be a very important.
In a bulky places like thigh, this key wire spike won't be a problem. This spike won't be a problem, but knee fractures, it might be a problem, and because of it, we defined and put a cover like this. We could cut this flush with the spike.
Okay, I'm going to suggest to have this discussion offline, and I like to thank you for this very nice workshop, and Dr. Mohammed will present you with a certificate of recognition.
Thank you.
Thank you.